Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about integration by partial fractions. In previous videos, we have encountered integrals of rational functions, and we've been able to integrate them with various techniques or patterns that we've already studied. However, I want to take a look at other rational functions that can't be integrated by those techniques. For example, this is a rational function that doesn't fit any of the patterns, so I don't have a technique right now that I can use to integrate that. In this case, because the degree of the numerator is greater than the degree of the denominator, the technique that I would use is I would actually do the algebraic division, break it down into different terms that I can then integrate. So that's not really partial fractions. I will do this example at the end of this video in case you're interested. However, what I want to focus on is rational functions such as this, where the degree of the numerator is less than the degree of the denominator, and the denominator can be factored. Those are the types of functions that we're going to learn how to integrate by partial fractions. Before I actually get into showing you how we break it down into its partial fractions, let's take a look at this difference of fractions. In order to subtract these fractions, I need a common denominator. So here I'm going to multiply the numerator and denominator by x plus 2. I need a common denominator before I can add or subtract any fractions. So now I'm going to multiply numerator and denominator by x minus 1. Now that I have a common denominator, I can add, or in this case subtract. So I'm going to have 2 times x plus 2 minus x minus 1 over this denominator. I'm now going to do the multiplication and then combine like terms. So I'm going to have 2x plus 4 minus x minus minus is plus 1. Let's multiply out this denominator. So we're going to have x squared plus 2x minus x will be plus x. Minus 1 times 2 is minus 2. So 2x minus x is x. 4 plus 1 is 5. The reason that I did that is I wanted to start off with the partial fractions and show you how you can combine those to get a more complicated fraction. And that's what we had here. But it's more difficult to take this and break it into a sum or difference of fractions. So we need to learn how to do that first. And then once we've done that, then the integration becomes much simpler. So in order to integrate this, what we want to do is break it down into its partial fractions. So let's not worry about the integration at this point. Let's just worry about this fraction. And I'm going to factor the denominator. It's a trinomial with a leading coefficient of 1. So I'm looking for two numbers whose product is negative 2, sum is a positive 1. Those two numbers are positive 2 and negative 1. So my factors are going to be x plus 2 and x minus 1. I know that this can be broken down into the sum of two fractions, one whose denominator would be x plus 2, but we don't know the numerator. I'm going to call that a. Plus the other fraction will be x minus 1. I don't know the numerator. I'm going to call it b. In order to find a and b, my first step is to multiply both sides of this equation by my lowest common denominator of x plus 2 times x minus 1. I'm going to do that the long way so that I don't lose anybody. So when I multiply this side by that lowest common denominator, both of these factors will cancel and I'll just be left with x plus 5. When I multiply the right-hand side by my lowest common denominator, I have to multiply each term. When I multiply this term, the x plus 2 factor will cancel. I'm going to be left with a times x minus 1. When I multiply this term by it, the x minus 1 factor will cancel. I'll be left with b times x plus 2. My goal is to find a and b, and there's a couple of different ways that I can do it. I think the easiest way is to choose values of x that make this 0, and then to choose a value of x that makes that 0. I'll show you what I mean. To make this 0, x has to equal 1. So we're going to choose x equals 1 and put that x value in this whole equation. So I'm going to have 1 plus 5 equals a times, when I put a 1 in, that becomes 0. And 1 plus 2, so I'll have 6 equals, that's gone, 3b. So I get b equal to 2. Now I'm going to do the same thing, but I want to make this equal to 0. So I'm going to let x equal negative 2. And I'll plug that in. So negative 2 plus 5 will equal a times negative 2 minus 1 plus b times negative 2 plus 2 is 0. So that's gone. So I'm going to have 3 equals negative 3a. So a is equal to negative 1. Plugging those values in for a and b, this is what the breakdown of that fraction is. Now that I have that, now let's integrate. So the integral of this will be the integral of this whole thing, and I'm going to break it up. So it'll be the integral of negative 1 over x plus 2 dx plus the integral of 2 over x minus 1 dx. And before I can integrate that, I can pull those coefficients out front. So I've got negative integral of 1 over x plus 2 dx plus 2 times the integral of 1 over x minus 1 dx. And each of these fits our basic log pattern. Remember, if I have the integral of 1 over u du, that's going to be equal to the natural log of the absolute value of u. So I'm using that pattern, and I'm going to get natural log of the absolute value of x plus 2 plus 2 times the integral of 1 over x minus 1 will be the natural log of the absolute value of x minus 1 plus c. I can leave it like that, or I can simplify by using some properties of logs. The properties of logs can come in handy to help you simplify this. If you have the addition of two log terms with the same base, you can combine them with multiplication. If you have a difference, you can combine them with division. And if you have a coefficient, you can express that as an exponent. So a times the natural log of m is equal to the natural log of m to the a. So what I'm going to do, I'm going to rearrange these, and I'm going to write the positive term first. That exponent, I can use this property of logs to write this as the natural log of x minus 1 squared. Now I don't really need the absolute value signs anymore, because anytime something is squared, it's always automatically going to be positive. And that's why we have the absolute value signs in there, because you can't find the natural log of a negative number or a negative value. So I don't really need the absolute value signs anymore. I do here though, because there are different x values that would make this negative. And then I'm going to use this property to combine these two terms into one log term. So it's going to be the natural log of x minus 1 squared over absolute value of x plus 2. It wouldn't be wrong if you had the absolute value signs around the whole thing. In our next example, we have the integral of x plus 1 over x cubed plus x squared minus 6x. So the degree of the numerator is less than the degree of the denominator, and I'm going to show you that we can factor this denominator. So let's not worry about the integral just yet. Let's write this as, first of all, I'm going to factor out the x. So x plus 1 over x times x squared plus x minus 6. Again, we have a trinomial with a leading coefficient of 1, so I'm looking for two numbers whose product is negative 6. So they multiply to equal negative 6. They add to equal positive 1. So that's going to be positive 3 and negative 2. So my factors will be x plus 3, x minus 2. So I was able to factor the denominator. Now I have 3 factors. And in order to break this down, I'm going to break it down into 3 fractions. So x plus 1 over x times x plus 3 times x minus 2 will be equal to, the first denominator will just be x, so it's going to be a over x, plus the next fraction will have a denominator of x plus 3, and I don't know the numerator, I'll call it b. And the last fraction will have a denominator of x minus 2. I don't know the numerator, I'll call it c. I'm going to multiply both sides of the equation by this whole denominator. I'm not going to show it this time because it's just going to get too messy. But when I multiply this side of the equation by this, everything will cancel and I'll be left with the numerator, which is x plus 1. When I multiply this fraction by this, the x factor will cancel and I'll have a times x plus 3 times x minus 2. When I multiply this fraction by this whole thing, the x plus 3 will cancel, so I'll have b times x minus 2. And lastly, when I multiply this term by this lowest common denominator, the x minus 2 will cancel, and I'll have c times x plus 3. Again, I want to choose values of x that are going to make these factors equal to 0. So there's 3 different numbers I'm going to choose. And that will give me my values for a, b, and c. So let's start off with, let's let x equal -3. Putting a -3 in for x, we have -3 plus 1. -3 plus 3 is 0, so this whole term will be 0. Similarly, -3 in there will be a 0. So both of those terms are 0. So I get -2 equals -3 minus 2 is -5 times -3 is +15. So b will equal -2/15. Let's replace b with -2/15. Now let's choose 2 for x, because that'll make this factor 0. So we have 2 plus 1 when we put a 2 in for x. This becomes 0. This becomes 0. So 3 will equal 5 times 2 is 10 times c. So c will equal 3/10. Let's plug 3/10 in for c. And lastly, let's make x equal to 0. Plugging a 0 in for x, we get 1 equals a times 3 times -2. This term will be 0, and this term will be 0. So we get -6a equals 1. So a is equal to -1/6. Plug that in for a. So we've successfully broken this fraction into the sum of those 3 fractions, and now we can integrate. So now I've expressed this integral as the sum of these 3 integrals. And before I integral, I'm going to take each of these coefficients out in front of the integral sign, just to make it a little easier. Each of these terms can be integrated using our basic log form. So this will be -1/6. The integral of 1 over x dx is the natural log of the absolute value of x. Minus 2/15 times the integral of 1 over x plus 3 dx will be the natural log of the absolute value of x plus 3. Plus 3/10 times the integral of 1 over x minus 2 dx will be the natural log of the absolute value of x minus 2. And in this case, I probably would leave it like this. It might get a little bit too messy because of all of these coefficients to use your properties of logs. In both of these examples, what we had were factors that were linear. X is a linear factor, x plus 3, x minus 2. It means a polynomial with degree 1. And there were no repeated factors. So this was non-repeated linear factors. In the next video, I'm going to talk about how we find the integral of repeated linear factors. So maybe we have x times x plus 3 times x plus 3, so it's repeated. So it's a little bit different, so I just want to cover that. And then after that, I want to do a video on if you have quadratic factors. So factors with degree 2 and also non-repeated and repeated. So go ahead and take a look at the next videos if you're interested in learning more about partial fractions. However, if you're interested in learning how to integrate that one example I had at the very beginning of this video, where the degree of the numerator was larger than the degree of the denominator, I'm going to show you how that's done right now. So this is the example I was referring to. We have a rational function where the degree of the numerator is higher than the degree of the denominator. So what we need to do here is do a division. We need to divide this into this and break it into separate terms that we can integrate. So we're going to divide x minus 1 into x cubed. We're going to go in descending order. There's no x squared term, so I put 0x squared. Plus x. There's no constant term, so I'm going to put a 0. Now I'm going to do the division. X goes into x cubed, x squared times. So x squared times x is x cubed minus x squared. Now I subtract, and that becomes 0 minus negative 1 becomes positive 1x squared. I bring down the next term. So x goes into x squared x times. So x squared minus x. When I do the subtraction, x squared minus x squared is gone. X minus a negative x will give me 2x. And I bring down the next term. And then I multiply by 2, so I get 2x minus 2. I do the subtraction, 0 minus a negative 2 is 2. So x cubed plus x over x minus 1 will be equal to x squared plus x plus 2 plus the remainder over the divisor of x minus 1. Therefore, the integral of x cubed plus x over x minus 1 dx will be equal to the integral of x squared plus x plus 2 plus 2 over x minus 1 dx. And I can integrate term by term. It's kind of a long way of doing it, but I don't want to lose anybody. Again, let's pull this coefficient out front. So the integral of x squared dx is 1/3 x cubed. The integral here is 1/2 x squared. Integral here is 2x. And then I have 2 times, this is my log form. So 2 times the natural log of x minus 1 in absolute value signs plus c. So make sure you do that division and break it down, and then hopefully you'll end up with something that you can integrate.